Hello there, everybody. Thanks for watching another math video. I hope you guys are doing well. This video is going to be about this question: what is a radian? Okay, you've seen that on your calculators. You've seen degrees and radians, and they change some of the numbers that you get. So, what exactly is a radian? All right. Well, the word radian actually comes from two other words. It comes from the word radius, and it comes from the word angle. When you add those two words together, radius plus angle, you get radian. So a radian is kind of like a radius angle, all right? Which is what exactly? What is a radius angle? Well, here's kind of my informal definition of a radius angle. A radius angle is a central angle in a circle that is based on the circle's own radius. Okay, so the size of the angle is dependent on the radius of the circle. Does that make sense? Maybe not. Okay, so let's back up a little bit, and you'll see that description is a good description, but it may not make sense yet. First off, let's talk about degrees. Do you know why there are 360 degrees in a circle? If you do, you're among the elite on our planet, because really nobody really knows why there are 360 degrees in a circle. We think that it is based on ancient numbering systems that were based on the number 60, but we're not exactly certain where 360 came for a circle. But it's a good number, because if you're going to divide a circle into 360 equal parts, those parts are kind of small. So you can have a lot of precision, and precision is good. All right? So because degrees are small, you get this precision, and so that makes them useful. Also, 360 as a number has a lot of factors, all right? You can divide 360 evenly by lots of different numbers. That means you can take a circle and divide it into equal sections of lots of different numbers of sections that are all even. So you can divide a circle into 2 parts, into 4 parts, into 6 parts, into 12 parts, into 10 parts, into 5 parts, into 20 parts. You can divide a circle into lots of different ways to have evenly divided numbers, because 360 has a lot of factors. Okay, so 360 is a good number to use if we're going to use a number, but it's kind of arbitrary. All right, we just say that there are 360 degrees in a circle because we said so. That's it. It's, in a sense, it's kind of artificial, and some people have a little problem with that. So for that reason, and for a lot of other reasons, people started thinking about other ways to look at a circle and the angles and how you divide a circle, okay? So someone came up with this. What if you took the radius of the circle and used it as kind of like a unit, or kind of a measuring stick, let's say. We took the radius and kind of wrapped that length around the edge of the circle to make an arc of the circle, and then we joined the end of that arc, the ends, with 2 radii. The angle that those 2 radii form is called 1 radian. All right? That's how 1 radian is defined. It's set up there as a radius angle. It's what you get when you take the radius of the circle and wrap it around the edge, and then connect both endpoints of that arc length with a radius. The angle formed by those 2 radii is 1 radian. Okay? That's what a radius angle looks like. Okay? But there's something much deeper and much more important here. What a radian really does is it expresses the ratio of arc length divided by radius. And I know we kind of went off in a different direction right there, so slow down and think about that for a second. A radian is the ratio of arc length divided by radius. So the arc length divided by the radius, that's the measure of that radian angle. That's how we get a number for the radian measure. All right. For example, if I had a circle, and let's say the radius of that circle was 5 centimeters, and I had an arc length marked off that was 8 centimeters long, the angle that's formed by those 2 radii at the endpoints of that arc is just 8 centimeters divided by 5 centimeters, which is 1.6 radians. The centimeters kind of cancel each other out in that fraction, right? Those of you who've been in a science class, you know, your dimensional analysis is all about, canceling out units, right? And that's what happens here. That 8 centimeters divided by 5 centimeters means no more centimeters. It's just that ratio, 1.6. we're calling it 1.6 radians, but it's really just that ratio, all right? So this angle here is equal to the arc length divided by the radius. That's our calculation for radian measure, all right? And that little formula that you're seeing right there actually opens the door to some other formulas that you are just starting to use about circle measurements that are pretty interesting, and we could talk a lot about those formulas, but we're not going to in this video here. This video really is just about this notion here about what a radian is, and I want you to focus on this thing. It's the ratio of arc divided by radius length. Okay, so instead of going down the formula path, what we're going to do is answer this very important question, a very important basic question. How many radians are there in a circle? Okay, well, we know there's 360 degrees, but how many radians are there? So a radian, as we've said, is what you get when you take one radius length and wrap it around the edge of the circle there. Okay, so that's what 1 radian looks like. If you did this again, now we have 2 radians there on the screen. And so from there, you know, how many more radians would it take to fill up the whole circle? And you can just kind of look at that, look at those 2 radians there, and probably come up with an answer something like, well, it looks like it's going to be about 6. Each one of those radians looks like it's about 1/6 of the circle. All right? So yeah, about 6. Okay, well, let's see. Let's try to be more precise than just saying about 6. And since what we're doing here is we're talking about the circumference of the circle, let's think about this for a second. The circumference of the circle is 2 pi times radius, right? Let me repeat that. 2 pi times radius. And remember, we are asking how many radians are there in a circle, all right? So each time you make one more radian going around the circle, you're doing that by taking one radius length and wrapping it around the circle. So we've done that 2 times. If I did it 3 times, okay, so that's 3 radians, and you can see I've got about half a circle there. If I kept going, 4 radians, 5 radians, 6 radians, and yes, I'm just doing this freehand. I'm not really using any kind of instrument to measure these, but this is what it looks like when you do. And so we've got 6 radians plus a little bit more. We didn't quite make it all the way around the circle with 6 radians. There's this little fraction of a radius length right there. And, you know, what is that? Wow, it's 6 plus how much, right? So, well, okay, back to the formula there. 2 pi times radius. That's the circumference of a circle, all right? 2 pi, if you do that on your calculator, 2 times pi is 6.28 something, all right? So that's what 2 pi is. So does that mean that that little fraction of a radius there is about 0.28? Well, yeah, it is. It's about 28% of a radius, okay? And in fact, we can be more precise than that, because 6.28 ... that's not very precise. That's just an approximation. But it turns out that there are exactly 2 pi radians in a circle, just what the circumference formula says. Circumference is 2 pi times the radius. And each one of those radius lengths wrapped around the circle makes 1 radian angle. So there are exactly 2 pi radians in a circle. There's not about 6, there's exactly 2 pi. That's how many radians are in a circle, all right? So there's 2 pi radians in a circle, and that must mean that 2 pi is equal to 360 degrees. Right? Yes, it is. So now we're talking about different units of measuring angles. And so 2 pi radians is the same as 360 degrees. Well, what about half a circle then? What about some other angle measurements? You know, half a circle. What's that in radians? Well, just divide both sides by 2, right? And you get pi. Pi radians is 180 degrees. Pi is half a circle. Okay, so what about 90 degrees then? Let's just keep going. Let's get some other commonly used angles, like 90 degrees. Well, that's just dividing both sides by 2, so it's pi over 2. Pi over 2 radians is the same as 90 degrees. So pi over 2 is a quarter of a circle. Pi over 2 is a fourth of 2 pi. So all these other fractions of pi that we can come up with, pi divided by 4, all right, well, that's pi divided by 4. 180 divided by 4 is 45, all right? What about pi divided by 3? Pi divided by 3, it would be the same thing as 180 divided by 3, which is 60. What about pi divided by 6? These are all commonly used radian angles, and their degree equivalent here, okay? And we could come up with lots more too. And they're all kind of based on this basic relationship between pi radians and 180 degrees, half of a circle. All right, so you will do some more work with this. This little slide right here kind of gives you some of the basics, and you can use this to come up with other measurements as well. All right, so to summarize here, what is a radian? Well, a radian can be thought of as a unit of measurement for angles, an alternative unit to degrees. But it's more than that, all right? A radian is actually defined as the ratio of arc length divided by radius. It is also a unitless real number. That's kind of the essence of what radians really are, right? There was this example that we did earlier in this video, 8 over 5, and the units canceled out, right? It's a unitless real number. We put the word radian on there just to kind of give us something to think about as we use this, but really the radian as a unit is kind of a ghost. It doesn't really exist. And a radian really is just a real number, which means that we can use it in lots of different situations. And in my opinion, that's why radians are really cool. Okay? So anyway, thanks a lot for watching. This was a little bit longer than usual for my videos, but I hope you got something out of it. It's an interesting topic, and you're going to be using radians a lot in other math courses. A little bit here, but a lot later on. Okay? So this is kind of food for the future. All right. Anyway, thanks very much for watching. I hope you're doing well and have a wonderful experience.